Let's study 10th Standard ICSE Chemistry, Chapter 3B, Analytical Chemistry. Now, if you are given a few salts, and most of them are white, how can you identify which salt it is? In this chapter, we shall study how to identify the cations, that is, the basic radicals, the metallic ions, calcium, magnesium, ferrous, ferric, copper, zinc, and lead. When we react these salts with certain alkalis, and in this chapter we shall use sodium hydroxide or ammonium hydroxide, we see that in the test tube we get a precipitate. For example, when calcium chloride reacts with sodium hydroxide, we get calcium hydroxide precipitate, which is a white precipitate. And when ferric chloride reacts with ammonium hydroxide, we get the precipitate called ferric hydroxide, which has a reddish brown color. So based on the solubility and the color of the precipitate, we can find out which salt it is, or at least the cation part of it. How to find the anion? Well, for that we'll have to study some other reactions in the chapter Practical Chemistry. So here, sodium hydroxide, it dissociates completely to give a high concentration of hydroxyl ions, and ammonium hydroxide, it gives a low concentration of hydroxyl ions. So in which situation we should use which of these two reagents depends on the precipitate being formed, which we shall study in detail shortly. Also, I must tell you that there are three metals which form amphoteric oxides and hydroxides. They are zinc, lead, and aluminium. If you react these three metals with a conch alkali like sodium hydroxide, they will react to give you a salt and hydrogen gas. Now usually such active metals react with acids to give salt and hydrogen gas, but these three metals will react even with alkalis like hot and conch, sodium hydroxide and potassium hydroxide to give you the salt and hydrogen gas. In the aluminium's reaction, however, water is also used in the reaction. Similarly, if you look at the reactions of their respective oxides and hydroxides with the alkalis, again you get salt plus water. So it's like a neutralization reaction where these oxides and hydroxides of lead, zinc and aluminium, they act like an acid and they react with the base to form salt and water only. Otherwise, usually metallic oxides and hydroxides are basic in nature, but these are amphoteric. Now let's study the reactions with sodium hydroxide. If you have a calcium salt, see the anion can be any, chloride, sulfate, nitrate, the reactions will be similar. So any calcium salt reacts with sodium hydroxide to give you a white precipitate which is insoluble even in excess of sodium hydroxide. By the way, calcium hydroxide is slightly soluble. It is called slaked lime. On the other hand, magnesium sulfate will also give us a white precipitate, but it's a dull white color, and even that is insoluble even in excess of sodium hydroxide. Ferrous salts, when reacted with sodium hydroxide, shall give you a dirty green precipitate, that is iron 2 hydroxide or ferrous hydroxide, insoluble in excess of NaOH. Whereas ferric salts like ferric chloride shall react to give a reddish brown precipitate called ferric hydroxide or iron 3 hydroxide, insoluble even in excess. Note that ferric chloride is always stored in an airtight container because it is deliquescent, so it can easily absorb the moisture from the atmosphere and become a solution. Next, copper sulfate. Well, that's a blue salt. So copper salts are blue or green in color. When you react a copper salt with sodium hydroxide, you will get a pale blue precipitate, which is copper 2 hydroxide, and it is insoluble in excess. Next, zinc salts. Now, zinc salts, when reacted, will give you zinc hydroxide, which is a gelatinous white precipitate. But if you use excess of sodium hydroxide, this salt will react with the excess sodium hydroxide to form a soluble salt. So in the end, you get a colorless solution. The precipitate, which was visible earlier, will disappear when NaOH is used in excess. So the next equation is lead salt. When that is reacted with sodium hydroxide, again, it will give you a chalky white precipitate. And even here, in excess of NaOH, this precipitate will disappear and it will leave you with a colorless solution. Now let's see the reactions with ammonium hydroxide. With ammonium hydroxide, calcium salts will not give any precipitate because ammonium hydroxide is a weak alkali. It gives you a low concentration of hydroxyl ions, and so no PPT can be seen. On the other hand, magnesium salts will give you a dull white precipitate, insoluble even in excess. Ferrous salts will similarly give you dirty green precipitate, insoluble even in excess. And ferric ferric salts like ferric chloride will give you reddish brown precipitate, insoluble even in excess. So these observations were similar to the ones in NaOH reactions. Copper salts, on the other hand, give you a different reaction and observation with ammonium hydroxide, because here initially, yes, pale blue precipitate is given, but in excess of ammonium hydroxide, this pale blue precipitate will react to form a soluble salt. So the precipitate will disappear and the whole solution will become inky blue. On the other hand, zinc salts will form a white gelatinous or dirty white precipitate, but yet again, even here, it is soluble in excess, just like it was with NaOH. However, lead salts will give you a chalky white precipitate, and even in excess of NH4OH, they will not be soluble, unlike what happened with NaOH. Now, armed with this knowledge about the solubility and the color of the precipitates formed, we can answer questions like, how will you distinguish between calcium chloride and magnesium chloride? Well, if you're given a calcium salt and a magnesium salt, if we react it with sodium hydroxide, then both of them will give us a white precipitate, which is insoluble even in excess of sodium hydroxide. So that cannot be used. We'll use ammonium hydroxide, because when we add ammonium hydroxide to both the salts, then calcium chloride or calcium salt won't give any precipitate, whereas a magnesium salt will give a white precipitate insoluble in excess. So there's a difference in observation, thus helping us to distinguish between them. Now let's talk about zinc salt and lead salt. How to distinguish between them? Again, if you use sodium hydroxide, both of them will give us the same observation, because both of them will react with sodium hydroxide to give you a white precipitate, which is soluble in excess. And we can't really distinguish if it is curdy white or gelatinous white. So we won't use NaOH. Instead, again, we will use ammonium hydroxide, because with ammonium hydroxide, zinc salts will react to give you a white precipitate, but in excess of ammonium hydroxide, it will dissolve. And in the end, you will get a colorless solution, which won't happen with lead salts. In lead salts, if you react them with ammonium hydroxide, even in excess, we will get a white precipitate in the end. What if we have to distinguish between a ferrous salt and a ferric salt, like ferrous sulfate and ferric sulfate? We can use sodium hydroxide here, because when they will react with sodium hydroxide, then the salt which gives a dirty green precipitate will be a ferrous salt, and the salt which gives a reddish brown precipitate will be the ferric salt.
Now in the textbook, in the introduction, cancel the first 2 points. The fourth bullet, mark it as a GR. Why do we use sodium hydroxide and ammonium hydroxide in analytical chemistry? Because they dissociate completely and partially respectively to give hydroxyl ions. And these hydroxyl ions give us the respective precipitates with a unique color and different solubilities, which helps us to distinguish between the cations of the salts. Color of salts. Well, mark it as read. That means you need not learn it. It's just extra general information, general knowledge. Notice how such salts are usually colorless, whereas these salts have these usual colors. The anions may also give it some characteristic color. These equations have to be studied by heart. As I had explained earlier, for each equation, we have to mention the down arrow, PPT, and each PPT has a particular color and solubility in excess, with the help of which we can know what is the cation present in that salt. Now, if you had to distinguish between, let's say, a calcium salt and a magnesium salt, we can't use NaOH because both will give you white PPT insoluble in excess. So that is why we have a second option of ammonium hydroxide, because here the calcium salt will not give us any PPT, and this is a GR, mark it as a GR. Whereas the magnesium salt will give us a white PPT, which is insoluble in excess. That's how we can distinguish between them. Notice that for NaOH, zinc and lead salts will not give PPT in excess, because the PPT will dissolve in excess. Whereas for ammonium hydroxide, copper and zinc salts will dissolve in excess. Now there is an alternative equation given. Cancel the alternative equations, just that second equation is enough. Learn the names of the complex salts as well. Whenever you write equations in exam, they should be balanced, but when they ask you to differentiate, no need to write the equations. Next, we have equations for the amphoteric metals and amphoteric oxides and hydroxides. It is compulsory to write conc below NaOH or KOH in these equations, and notice how aluminium has water involved as well. Hydrogen is released. Displacement reaction. Now here they are called amphoteric oxides and hydroxides because not only do they react with acids like any other metallic oxide, but they react with conch alkalis as well, as you can see, to form salt and water only. So that's a neutralization reaction. Learn the names of the salts too.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.